I'm aware that I'm talking to an interdisciplinary audience here, so let's just lay some basic groundwork. One of the most iconic images of finance, which I'm sure you're all familiar with, is the trading pit. And it'd be something like this, something like how I'm standing here. You'd have traders hustling and bustling, they'd be holding up cards, they'd be making hand signals, and so on and so forth. And this is what we think of when we imagine financial markets. And I think that image stays with us very strongly. But in the last 15 years, something fundamentally has changed about the nature of financial markets. We're no longer dealing with situations where people are directly interacting. Instead, almost all trading in some major asset classes, such as stocks, for instance, and particular types of derivatives, are done via computer networks. It's the computers that do the trading. High-speed algorithms are employed so that you may have trades being performed in the millisecond or microsecond time frame. That is at a temporal level at which human beings cannot perceive what is happening in financial markets. And what my project is about, and what I'm going to talk to you about in this short presentation, is what does this mean for financial regulation? Financial regulation is not a subject which many people are going to get excited about in this room, I'm sure, but I'll try to make it as interesting as I can, because something is going on in the regulatory sphere right now which I think is very significant and can also speak to some of the themes that we've been looking at already in this conference, such as some of the things that Louise was talking about around making aspects of reality visible that are not perceptible to human beings directly. Okay, so to begin this presentation, I want to look at the reasons why regulators are interested in this transformation of financial markets. Okay, the most famous event, which some of you might be familiar with, I'm not sure, but I'll go through it. 2010, 6 May, this happens. We have this enormous thing called the flash crash. Within a matter of minutes, financial markets plummeted, and there's newsreel you can see of this, where the commentators on the news are watching what's happening in financial markets, shocked, literally traumatized by what's happening. And some of the commentators on this have quite simply described this event as traumatic. You have here what was a 9% drop in the stock market, and it occurred within the matter of minutes. So obviously this is not something that could have happened in the era before computers and high-speed algorithms took over financial markets, and regulators don't like this kind of thing. Regulators find this a disturbing behavior and a disturbing development. We also have this event, 2012, one of the largest market maker firms in the world, Knight Capital. It rolls out an algorithm. It hasn't tested it properly. Within 45 minutes, the algorithm loses the company $440 million. The algorithm is rogue. It's not behaving properly. And this firm, Knight Capital, were eventually issued a cease and desist order by one of the main regulators in America. Again, another disturbing event connected to the computerization of financial markets. Here's another event, more, in the news a bit more nowadays. The British trader Navinder Saral. He's recently been, the request has come from US authorities for this trader to be extradited to the United States from Britain. He is accused, probably rightly so, of a particular form of trading manipulation called spoofing, where you use algorithms to attempt to fool the market, to fool other traders into behaving in ways that are not beneficial to them. And this sort of market manipulation for which Navinder Saral stands accused was simply not possible, or at least not in this form, before financial markets were automated and computerized. Oh, and I should say, finally, there has been, of course, this wider cultural backlash or reaction to what's happening on financial markets, from novels to accusations that HFT, high-frequency trading, is leading to broken markets. We've had accusations that AI trading is leading to the stock market and wider financial markets being rigged. And most famously of all, Michael Lewis in Flash Boys portrays the development of financial markets of having reached the point at which the average investor will necessarily get fleeced by the highly technological, computerized forms of trading that are so prevalent today. So, what are the reactions at the regulatory level? Now, this is the boring bit, but I'll try to spice it up as much as I can. One of the main ideas that has come through, and one of the most radical ideas that financial regulators have been floating about these kinds of events and these developments of markets, is the idea of algorithmic supervision. So, in essence, what this is saying is, in the old world, we had to supervise trading firms, we had to supervise individual traders to see that they're not up to mischief. But with the transformation of financial markets into this highly technological, computerized realm, well, regulators are starting to recognize that maybe we need to be supervising the individual algorithms. So in the review of MiFID, which is a large European regulation, there was a proposal originally that trading firms should have to give detailed descriptions of their algorithms to the regulators. And more recently, with the regulation automated trading, which is currently kind of going through the works in the United States, there has been the suggestion that trading firms should lodge the code of their algorithms on an ongoing basis at an external data repository, potentially with the ability for regulators to go into this repository, go into the code, and look at what trading firms are doing. And of course, this has been massively, massively controversial. Why is that? Well, although none of these proposals actually say, you know, regulators are going to be inspecting the code on a real-time, direct basis, the financial sector has reacted very strongly against this, seeing it as a kind of slippery slope towards full source code disclosure. And I picked up this quote. This was from the Financial Times, and more or less sums up the sentiment that's come from a much wider variety of actors. It's inconceivable that any firm should be expected to leave its intellectual property at the doorstep of government. And I call this the politics of code that is emerging in the regulatory sphere in financial markets. So that's the background. My particular research and what I've done interviews on and spent a lot of time investigating and reflecting upon is a potentially even more interesting development in the regulatory sphere. And I think this is where, hopefully, what I'm talking about will start to interest some of the people in this room. 2013, German authorities release the HighFrequency Trading Act. They are looking for an alternative to the idea of inspecting. Oh, okay. Sorry about that. They're looking for an alternative to the idea of regulators supervising algorithms directly. You know, they want to avoid this politics of code. So what they do is they come up with this ingenious suggestion about what we can do to monitor financial markets. We're not going to look at the individual code. We're just going to ask trading firms to identify their individual algorithms. So every time you submit an order to an exchange, you will grant, or you'll label, I should say, with a numerical code exactly which algorithm was responsible for that trade. And coming to some of the themes that Louise was talking about, this was quite simply an attempt to make visible the algorithmic space. Currently, on financial markets, you have this enormous amount of data, you know, bids, offers, you know, huge amounts of instruments being traded. But you cannot see the individual algorithms at work. If a trader is running 20 algorithms in parallel, you can't see these individual algorithms, so you can't really know what is going on. But if you ask trading firms to identify their individual algorithms, suddenly, for the surveillance officers at the major financial exchanges, they can see these algorithms. Algorithms become a discrete object which you can perceive, monitor, and so on and so forth. Now, what I want to argue for the rest of this presentation is that this idea, as ingenious as it sounds, and I'm very sympathetic to what regulators attempted to do in Germany, this idea has a number of difficulties, and in fact, there is an entanglement of the politics of code with some of the epistemic problems in this new device for seeing financial markets, which we can see at numerous stages of the regulatory process. I'll just try to take you through those as quickly as I can. Okay, so here's the first problem. We're going to ask trading firms to identify their algorithms. Fine. But if you're going to introduce such a rule, before doing it, you first have to say, well, what is an algorithm? We, of course, have this kind of generic idea of what an algorithm is as a series of decision steps or procedures. But in a financial setting, we need to know what specifically is a trading algorithm. And in fact, no one had ever really asked this question before. When regulators sought to define what an algorithm is and institute this new surveillance mechanism over markets, they had to kind of ex nihilo invent or discover what an algorithm is. And this was what really led to it. And there was a very long consultation process that culminated in their final definition. This is what a regulator told me. So just to give you a bit of background, at this point, they've been talking to trading firms all across Europe for about 12 months. We came to the question, so what is an algorithm really? When you discuss with market members, you get a multitude of different options. So one says it is each if-then clause is an algorithm, and the next one says my strategy is an algorithm. And so we have everything in between. So we have this interesting issue developing in the regulatory process. What is an algorithm? And a lot of the difficulties regulators were facing here go back to the fundamental split identity of an algorithm, which is both a strategy, an intellectual kind of procedure around a series of decisions, but something that also has to be expressed in terms of computer code. So that's the first interesting element of the story. Now here's the kind of the second interesting element. So this here is an example of some of the guidelines for implementing this rule. I really can't go into the details of this right now because its level of complexity borders on the Baroque, but just accept it for now. But anyway, they come up with these highly sophisticated procedures, incredibly ingenious, incredibly detailed. In my view, one of the most sophisticated attempts of financial regulators ever to implement these kind of rules. But still, they had a problem. They had this idea of what is a material change in an algorithm. How do we know when one algorithm becomes a different kind of algorithm, and how do we decide when we need to label it differently? They ran up against a certain point at which, if they wanted to get really, really precise about what an algorithm is, they would have to define it relative to code. You have to go to the computer code at a certain level to make these rules highly precise. But, as I said from the start, the initial motivation for this entire project was precisely to avoid having to get access to code or define anything relative to code. So you have, in a way, the politics of code that was being attempted to be overcome with this device is resurgent at a later level of the regulatory process. And here's the result. So you have what looks like a series of very precise rules laid out in the implementing guidelines for this. But, in fact, when I went and interviewed high-frequency trading firms, spoke to the compliance officers there, found out, how are you implementing this rule? You know, it's so complicated. What are you doing? Well, what I found was somewhat disturbing. In fact, every firm I spoke to was interpreting these rules in almost completely different ways. The way that they were interpreting what an algorithm is seemed completely different. What a material change in an algorithm is completely different. How do you decide when one algorithm has become a different algorithm? Completely different procedures. And one result of this is that the number of these identifiers that they attach to these algorithms is so completely different between different trading firms that it's really hard to know what, in fact, these identifiers are attempting to identify. So, for instance, one firm I spoke to in London say they have 5 algorithms. That's it. They only use 5 for the last 2 years. I spoke to another firm in the Netherlands. Apparently, they create 2,000 to 3,000 different algorithms every year. Spoke to one small trading firm as well in the Netherlands who say they only have 1 algorithm. There's no other ones. So this was what I think is one of the more interesting aspects of this rule, and something I want to hopefully reflect upon a bit when I write this up as a journal article. We really don't know what these identifiers that have been created in the regulatory process are representing. You get numbers for algorithms, but what exactly are they referring to? Not really sure. And maybe on top of that, the problem is here, there is a sort of resurgent element of the politics of code in the potential failure of this scheme. Now, I don't want to be too definitive about this, because I go between extremes here. Sometimes I think, wow, this is a great, successful scheme. I'm so impressed by what the regulators have done. Other times I think, well, maybe it's all a bit of a shambles. So the point is, the idea of representing these algorithms on financial markets, we fundamentally don't know if it's worked or not. So let me just wrap up. The politics of code has emerged as an interesting new development in the sphere of financial regulation. The German HFT Act is so interesting because it attempted to avoid that politics, and yet that politics and its kind of epistemic entanglements ended up resurgent within the regulatory process, which is why we don't know how successful this scheme is being. And to conclude, I think what this particular little case study shows us is that there is something very particular about the development of financial markets into this automated domain, which means it's hard to know or hard to disentangle the political and the epistemological. They're just so deeply entwined that there is this problem, and I think we have to come to terms with that, and what do we do about it? All right, thank you very much.